Today, the humble math tutor brings you the remainder theorem. The remainder, when polynomial p at x is divided by x minus a, is p at a. But if p at x is divided by this more complex binomial, the remainder is p at b over a. Let's prove this, but first let's get used to the idea of an associated division statement. That's part of the proof. If I divide 5 into 17, it goes in 3 times, giving you 15 and a remainder of 2. The associated division statement is that the dividend is equal to the divisor times the quotient plus the remainder. So if I'm dividing by, say, x minus a into the polynomial p at x, it will go in so many times, the quotient, and there'll be some steps, and you'll get a remainder at the end, quite possibly. In that case, let's work out the associated division statement. The dividend is equal to the divisor times the quotient plus the remainder. Now, if I let x take on the value of a in this equation, I would get p at a equals a minus a times q at a plus r. But a minus a is 0. So that gives p at a equals 0 times q at a plus r. 0 times anything is 0, and I have this result, that p at a equals r, which was what we were trying to prove in the first half. Right? That's the remainder when you're dividing by x minus a. The proof for the second half is similar. We're going to move straight to an example, though, to show our theorem in action. The remainder is 4 when this polynomial with a k here, an unknown coefficient value, is divided by 2x minus 1. Determine the value of k. Well, this is the more complicated binomial you can divide by, ax minus b, remember. So the remainder is p at b over a. And then just fill in the information from our question. So the remainder is said to be 4, and p at b over a is p at 1 over 2. Remember, it's ax minus b. So the b value is 1, and the a value is 2. So the b over a becomes 1 over 2. And we just solve the equation. So if I take this 1/2 and put it in for every occurrence of x up here, I'm going to get that 4 equals 6 times 1/2 cubed plus 5 times 1/2 squared plus k times 1/2 plus 6. Notice that k is the only letter which occurs in this equation. We should be able to solve for k. Let's simplify. So, giving myself some room, I'll move a little bit to the left. 4 equals 6 times 1/8 plus 5 times 1/4 plus k over 2 plus 6. Simplifying a little, 4 equals, now 6 over 8, that's 3/4, right? Plus 5/4 plus k over 2 plus 6. Why don't we multiply both sides of the equation by 4? That will eliminate all fractions. So to do that, I multiply this by 4, I multiply this by 4. Everything gets multiplied by 4. And that will give us, on the next line, 16 equals 3 plus 5 plus 2k plus 24. Cleaning up the right side before actually trying to solve, just add up the like terms you see. We have 8 plus 24 is 32. 16 equals 32 plus 2k. Subtract 32 from both sides, giving us negative 16 equals 2k. Divide both sides by 2 and you get negative 8 as the required value for k. If you enjoyed this video, please like, subscribe, and share. In the comments section below, please post suggestions on topics you'd like to see covered. Thank you.